From Department of Computer Science and Engineering, I would like to welcome all for video lecturer on Cyber Security course with Anna University syllabus on Regulation 2021. Unit 5 in Cyber Security course is Intrusion Prevention. The topic is types of firewalls. The third type of firewall is application level gateway firewall. An application level gateway, also called an application proxy, that acts as a relay of application level traffic, and the user contacts the gateway using a TCP or IP application such as Telnet or FTP, and the gateway asks the user for the name of the remote host to be accessed. When the user responds and provides a valid user ID and authentication information, the gateway contacts the application on the remote host and relays TCP segments containing the application data between the two endpoints. If the gateway does not implement the proxy code for a specific application, then the service is not supported and cannot be forwarded across the firewall. Further, the gateway can be configured to support only specific features of an application that the network administrator considers acceptable while denying all other features. The application level gateways tend to be more secure than packet filters. Rather than trying to deal with the numerous possible combinations that are to be allowed and forbidden at the TCP and IP level, the application level gateway need only scrutinize a few allowable applications. In addition, it is easy to log and audit all incoming traffic at the application level. A prime drawback of this type of gateway is the additional processing overhead on each connection. In effect, there are two spliced connections between the end users with the gateway at the splice point, and the gateway must examine and forward all traffic in both directions. Fourth type of firewall is circuit level gateway firewall. Circuit level gateway or circuit level proxy can be a standalone system, or it can be a specialized function performed by an application level gateway for certain application. As with an application gateway, the circuit level gateway does not permit an end-to-end TCP connection. Rather, the gateway sets up two TCP connection, one between itself and a TCP user on an inner host, and one between itself and a TCP user on an outside host. Once the two connections are established, the gateway typically relies TCP segments from one connection to other without examining the contents. The security function consists of determining which functions and connections will be allowed. A typical use of circuit level gateways is a situation in which the system administrator trusts the internal users. The gateway can be configured to support application level or proxy service on inbound connections and circuit level functions for outbound functions or connections. In this configuration, the gateway can incur the processing overhead of examining incoming application data for forbidden functions, but does not incur that overhead on outgoing data. An example of a circuit level gateway implementation is the SOX package. Version 5 of SOX is specified in RFC 1928. The RFC defines SOX in the following fashion. The first one is the protocol described here is designed to provide a framework for client-server applications in both the TCP and UDP domains to conveniently and securely use the services of a network firewall. The protocol is conceptually a SIM layer between the application layer and the transport layer, and as such does not provide network layer gateway services such as forwarding of ICMP messages. SOCs consist of the following components like SOC server, which often runs on a Unix based firewall. SOCs is also implemented on Windows systems, and the SOCs client library, which runs on internal hosts protected by the firewall. So, SOCs I-field versions of several standard client programs such as FTP and Telnet. The implementation of the SOCs protocol typically involves either the recompilation or relinking of TCP based client applications or the usage of alternate dynamically loaded libraries to use the appropriate encapsulation routines in the SOCs library. When a TCP based client wishes to establish a connection to an object that is reachable only via a firewall, it must open a TCP connection to the appropriate SOCs port on the SOC server system. The SOC service is located on TCP port 1080. If the connection request succeeds, then the client enters a negotiation for the authentication method to be used and authenticates with the chosen method and then sends a relay request. The SOC server evaluates the request and either establishes the appropriate connection or denies it. The UDP exchanges are handled in a similar fashion. In essence, a TCP connection is opened to authenticate a user to send and receive UDP segments, and the UDP segments are forwarded as long as the TCP connection is open. Thank you.